Hello, in this video, I am going to introduce how to make a capacitive touch sensor with an Arduino. This is the first part of the video, introducing the basic principle and instruction of how to make a touch sensor with Arduino. A capacitor is formed with two metal plates, separated by an insulator. The capacitance of the plate increases as the area of the plates get larger, and the distance between the plates become smaller. A touch sensor on a PCB is formed with an electrode and overlay, a thin layer of insulator material. The electrode represents one plate of a capacitor. The surrounding environment forms a parasitic capacitor of C0. When we make a contact to this electrode, with a finger, for example, it also contributes to the capacitance of the electrode. By taking a measurement of the capacitance directly, or by measuring some other effect resulting from the capacitance change, we can detect a touch of the electrode. By touching the lead of a resistor, a touch capacitance can also be formed. This is equivalent to the RC filter introduced in one of my previous videos. RC filter is a low-pass filter, which passes a signal with a low-frequency component, and attenuates a signal with a high-frequency component. One major application of an RC filter is filtering a PWM signal to generate low frequency, or even a DC voltage signal. Let's take a look at how the signal changes by adding a touch capacitor to a resistor. An input digital square wave passes through the resistor without any distortion of the signal. By touching the lead of a resistor, a touch capacitance is added to the resistor, forming an RC filter, which removes the high-frequency component from the waveform, resulting a smooth saw-tooth-shaped waveform. Using this property, we can use a microprocessor, or Arduino, connect each LED of the resistor to each input and output GPIO pins, and add some codes to detect the touch. The code starts by generating a rising pulse to the output pin, and waits until the input is read high. When high level is detected from the input pin, set the output back to low, and measure the time it took for this whole process. So, how is this possible for detecting a change of capacitance? Every digital input pin has a certain voltage level which it can detect whether the input signal is high or low. This is called VIH and VIL, and the values are 3 volts and 1.5 volts for the processor used in Arduino Uno. Using the code from the previous slide in this case, the output waveform will be generated as follows. When the capacitance gets larger, the waveform gets smoother, and as a result, the output waveform generation is extended to a longer period of time. By generating multiple pulses and measuring the time for these pulses, we can easily detect the change of the capacitance. Let me show you a simple demo using the Arduino. The demo is using just one 1 megaohm resistor, connected to pin 4 and 6, with pin 4 generating the pulse to the resistor. The code generates and detects multiple pulses with some added functions to discharge the input voltage to a low value. This is the simple configuration for demonstrating the capacitive touch sensor. You can see the resistor connected between pin 4 and 6 of the Arduino. In this serial monitor on the right, you can see that it takes 60 cycles for generating 30 pulses. As we touch the resistor lead on the pin 6 side, which is the input pin, you can see the cycle count increasing to 200 to 300 cycles. If we grab the resistor lead with 2 fingers, the cycle count increases to 400, which can be the indication that the capacitance have increased. Now let's connect the probe to visually see the waveform. Due to the capacitance of the probe itself, the cycle count can be increased. In my case, it increased to 150 cycles. From the waveform, you can see there are 30 pulses generated, and on the top of each pulses, the voltage folds back to 0 after reaching approximately 3 volts, which is clearly the VIH I explained earlier. By touching the lead of the resistor, you can see the interval of each pulses are increasing, resulting the increase of the overall processing time. I added an LED and a couple of codes to demonstrate a lamp with a touch sensor. In addition to this, there are many other things we can apply the touch sensor. In the next video, I will show you how to make a touch sensor on a PCB, with some useful features. So stay tuned. This is it. Thank you for watching. See you in the next video.